In this video of the Pure Math 1 course, I will be going through an example of a transformations problem. So let's have a look at this problem here. The graph of f of x, y equals f of x is shown. Sketch the following curves stating the equations of the asymptotes. Indicate where the curve crosses the coordinate axes. So we've got y equals f of x plus 2, y equals f of a half x, and y equals minus f of x to sketch. Now, we notice that there are in fact two asymptotes on this curve. This curve has the x-axis as an asymptote, and the equation of the x-axis is of course y equals 0. The equation of the y-axis is of course x equals 0. And we have a vertical asymptote where x equals 1. So the two equations of the asymptotes on the curve y equals f of x are y equals 0 and x equals 1. What we need to do is to sketch these transformed curves and state the value of their asymptotes and indicate where the curve crosses the axes. So for the first function, y equals f of x plus 2, if you remember, this is a translation parallel to the y-axis of factor 2. So we're moving it up by 2. So what happens to the asymptotes? Well, the vertical asymptotes, every point on that will be moved up, well, the whole asymptote will stay where it is, and so we still have the asymptote there where x is 1, but the other asymptote, y equals 0, the horizontal asymptote, will be moved up by 2, and so will look like that, where this here is 2. And the curve will be translated by 2. Well, this branch of it will be there, and the other branch of it, well, the point when it crosses the y-axis minus 1 will move up to plus 1, and the curve will look like that, and that will be 1. And that's how you would do that one. The second one, B, well, this y equals f of a half x, well, that is a stretch in parallel to the x-axis of factor 2. And so everything will be stretched parallel to the x-axis only, so the vertical asymptote will be stretched by 2 and will be moved from 1 to 2. Like that. And the horizontal asymptote, the x-axis, will stay the same. And so we'll have this branch of the curve will be like that. And the x-axis stays the same, still the asymptote, so the other branch of the curve is like that. It's not actually possible to know where the new curve crosses the y-axis, because we don't actually know the equation of the graph. We only know we only know the shape of the graph. We don't actually know the function, so we can't say where that point is. This here is 2. The third graph, C, y equals minus f of x. This is a reflection in the x-axis. So if we reflect the vertical asymptote, it will remain where it is. At 1, and so we'll reflect both parts of the curve. The one in the right quadrant will go to the go down to the bottom right quadrant, like that, and the one down in the bottom left quadrant will be reflected up to the top left quadrant, like that. In fact, like that, where this is, and the point minus 0 minus 1 will be reflected to the point 0 plus 1. So the equations of the asymptotes in each of the three curves. In the first one, the x-axis has become y equals 2, and the and the vertical asymptote has stayed the same as x is 1. The second one, we still have the x-axis remains, so it's y equals 0, and x equals 2 is the other asymptote, and in the third one, the asymptotes are the same as the original graph, and so that's x equals 1, y equals 0. Now, very important not to forget in this case the x-axis as an asymptote, and to state it even though it doesn't appear there because it is one of the axes, but there would be a mark in the exam for stating it, so be careful. Okay, now you can return to Study Smart, where you can find further questions to practice.